So lesson 2 of 4, we're going to stick with areas in geometry. We don't have to worry about calculus, really. We're going to stick with areas, and we're going to stick with this integral notation. And we're going to talk about the properties of these integrals. Okay, so this is read, just a reminder of how this read. This is read the integral from a to b of f of x dx. Okay, and we know this integral as an infinite sum. This is an infinite sum from a to b of a bunch of infinitely skinny rectangles. And when we sum up all these infinitely skinny rectangles with height of f of x and width of dx, this is really just an area. This is an area instead of an integral. You can think of this as the area from a to b between f of x and the x-axis. So it's almost like you can interchange integral with area, as long as you have this a to b. Now what's really important is that this a to b and where it's located on this integral matter. Order matters. If you want to go from A to B, A is going to be on the bottom. That's your starting point. And up at the top, the B in this situation, that's going to be your finishing point or your end point. Okay, and we've already looked at, curves from A to B above the x-axis and below the x-axis. I'm just going to remind you of what we would consider these areas to be. So if this is from A to B, well, starting at A going to B, we'd have all of these rectangles, and these rectangles that we would create would have a delta x or a dx, which is positive. The reason why it's positive is because we're starting at A and going to the right. Since we're going to the right, our dx is positive. And our function values up here are all positive because it's on above the x-axis. So this would be from A to B of f of x dx, a positive height times positive width. This area would be positive. And it doesn't matter if you're to the left of the x-axis or to the right of the x-axis. If I moved over here, the same thing would hold. I'd be moving from A to B in the positive x direction, and my function values that are my heights are also positive. So above the x-axis, our area is positive. Now below the x-axis, we talked about it, and I'll just show you exactly why. And I think I showed you last class. Because if we are moving from left to right, from A to B, the rectangles we create will have a positive width because we're moving from left to right. And now the heights, though, these function values that we use to create these rectangles, they are going to be negative. So all of a sudden, this is negative, this is positive, this area is negative. Yes, that's the next thing we're going to do. What happens if we move from right to left? What happens if we go from B to A? So even though it's the same, letters, it is completely different. Okay, this is read the integral from b to a of f of x dx. Or the area from b to a between my function and the x-axis. Let me try to give myself some space here. That's crazy. They're all connected. So let's look at this situation from B to A, above the x-axis. Well, my heights of my rectangles that I use, still going to be positive, but my width, since I'm going from right to left, that is traveling in the negative x direction, all of a sudden my dx's are negative. All of a sudden, the area from B to A above the x-axis is negative. And if we think about, just like Mr. Barron said, if we're going from B to A and we have a function underneath the x-axis, well, my heights are negative. And my width, since I'm traveling from right to left, that's going in the negative x direction, that would mean my widths are negative as well. We have negative widths times negative heights. All of a sudden, this area is considered to be positive. That might be tricky to remember all the time, so it's just really easy to remember this. If you have like the area from 2 to 3, let's go with just A's and B's, and we'll do another one. The area from A to B of f of x dx is going to be equal to the opposite of the area from B to A, or you can go vice versa. So maybe a quick example using numbers. If the area from 2 to 3 under my function is equal to 4, well, if I went from 3 to 2, that area is now negative 4. Okay? So order matters. Starts at the bottom, goes to the top. Very, very important to remember that. Order matters and location matters. Above the x-axis from left to right is positive. Below the x-axis from left to right is negative, and vice versa if you're going from right to left. All right, here's a new one. The integral from a to a under f of x dx. What do you think that is? No. Good guess, though? 0 is correct. If we just have no kind of x distance, well, we're not going to be able to fit any rectangles in that distance. So what's the area under this curve? It's just 0. You put a there. So if you're asked, what is the integral from 10 to 10 under some function like e to the x? Without knowing anything about e to the x, how it looks or anything, you can answer this as 0. Okay? Next one, we're just doing different properties of these integrals, these areas. If I have a constant being multiplied by my function. So here's a function. between a and b. And here is 3 times the function. So when it's 0, it stays 0. But if this is like 2, this goes up to 6. What do you think that's equal to? Let's say this area right here is 5. What do you think the area under the red line would be? 15 is correct. Maybe I can use numbers to make that easier. If this was, a height of 2 and this is a width of 5, you have a rectangle. All of a sudden, this would be a height of 6. The width is still 5. So it would be 3 times 5, which is 15. So this is just equal to your constant times the area under your original function. Okay? Next one. What if we add a constant? Let's say the area under this function, f of x, between a and b is also 5. And let's say instead of between a and b, I'll use a better example, between like 2 and 4. So I say that the area between 2 and 4 under f of x is 5. The question is, what is the area between 2 and 4 of f of x plus 3? Is it 8? We would think, right? But it's not. And it all comes down to this. If this area is 5, well, if I move this up 3, that 5 comes up here. But look how much more area I also have to account for. I have to account for an extra rectangle with a height 3 and this width of 2. So this would be a rectangle that is an area of 6. This total area would be 11. How do we get that? It's just the area under my original function plus we have a rectangle with a base from 2 to 4. This is by your interval. And the height is 3. We have to add an entire rectangle worth of area rather than just the number 3. So you can use that here. This would be a to b of f of x dx plus k times b minus a. There's other ways to do that as well that we'll see in the future when we reintroduce calculus to this lesson. Okay, so you shift up, the 5 stays here, and we have all this extra area that's a rectangle. Next one. Here's the function. I got 3 points. I got A, B, and C. I have the integral from a to b of f of x dx plus the integral from b to c of f of x dx. What do we think that's equal to? Miss Wise, what do you think? Exactly. Makes sense? Almost too obvious. This area plus this area gives you all of the area. Okay, that's good to know. Now, if I'm adding two functions, it's not really easy to see this using an example, so I'll show you here. Here are two functions. You have a green function, and let me just make sure you can write that down. Here's what it is. A function plus or minus another function. The area or the integral from a to b of those two. Okay, so here in green is the function y equals x. Here in blue is the graph of e to the x. Here in red is your green function values plus your blue function values to give you the red function values. The area under the green is this value. The area under the blue is this value. The area under the red is really ends up just being the sum of the two areas. It's almost too obvious, but it's good to just see that for confirmation. This is just the area under your first one plus or minus the area under your second one. Okay? So most of these are obvious. This guy makes sense logically. So we'll see when we do examples that makes sense. This one makes sense. The K makes sense. Really, the A to the A does. The one that's tricky is when you're adding a value. This is when it gets a little bit trickier. Okay? You have to think about adding more area because you are shifting a function when you're adding values to it. Okay? So let's do some examples. I'll give you information up top. You will use this information to answer the following integral questions. Okay, you do those and check your answers with a neighbor. 6. Now, when you do them, almost picture the areas in your mind. Picture some function between 0 and 5, and underneath this function, between 0 and 5, we have an area of 10. And then from 5 to 7, we have an area of 3 with that same function. Maybe that'll help. Check your answers with a neighbor once you get them. Make sure we remember that order matters. From 5 to 0, from 7 to 5. From 5 to 0. Okay, let's talk about these. Top left, what do we get for that? Negative 10. It's just the opposite of the area from 0 to 5, so that's good. From 7 to 7, that's going to be an easy question to answer, 0. Now, from 0 to 5 of the function plus 3. So from 0 to 5, the area under the function is 10. If I take this function and I shift it up 3 units, I get extra area underneath it. I don't know if I can show that because everything's stuck, but you get my drift. All of a sudden, if I shift it up, everything gets shifted up 3 units. This is still 10, but then we will have this rectangle of area. So it's got 10 plus a rectangle, that's 5 by 3. That's 10 plus 15. That's 25. Okay? Then from 0 to 7 will just be 0 to 5 plus 5 to 7. That's 13. Then from 7 to 5 of negative 3 f of x. Well, from 5 to 7 of negative 3 f of x, that would be negative 9. But since it's going from 7 to 5, it is the opposite, so that is positive 9. And finally, from 5 to 0, well, that's just going to be the opposite of from 0 to 5. From 0 to 5, it would be 10 plus 5. Since I'm going from right to left, though, it's going to be the opposite, which is negative 15. Questions about those? Okay, some more. And this is all dx. So I know the area from 2 to 6 under f is 10. I know the area from 2 to 6 under g is negative 2. We want to know the area from 2 to 6 under f plus g, and I want to know the area from 6 to 2 of g minus 2f. First one should be a piece of cake. Second one might need some thought. This is how you would show it one step at a time. Might be just probably even more complicated than just kind of doing it. This is the opposite of -2 minus 2 times 10, which is 20. So that's -22. Take the opposite of it, positive 22. Which might be easier if you just like stay right here and just do -2 minus 20. Take the opposite of it. Okay? Questions about those? Okay, some more. Last set before we do some graphical ones. I know, we can do it. Bell to bell, Mr. Barron. Just because it's not fourth period B day doesn't mean we don't go bell to bell. DX's at the end of all these. What about the last one? Anybody? Okay. Keep working on it then. Sorry. Trying to rush you. That's the key. It's the whole AB plus BC is the area from A to C. -7 is it. The area from 0 to 5 we got is -5. We're trying to find the area from 0 to 3. Well, the area from 0 to 3 plus the area from 3 to 5, which we know has to be 2. What does this guy have to be? This guy has to be -7. Okay? AC equals AB plus BC. That's how we get this last one. A little bit tricky, that one. All right. Graphical example is really the same. I mean, I could add 2. I could subtract 3. You know, you just have your rectangle that you have to add on. So we have a couple of those on your homework. Also, there's some questions like this. This is a good question to do and be able to do. You'll see these on your homework. set up a definite integral that will give the area of the region, but do not calculate the area. Well, for this one, I don't want you to calculate that it's 15. That's obvious. But I want you to say, oh, it's the area from 0 to 5 under this function 3 dx. Okay, so the second one, the integral, the area from -4 to 4 under this function 4 minus absolute x dx. See how those go? They should be kind of easy. You're using the function and you're using this integral to just say, you know, find the area of. And of course, we're going to go from left to right unless we're stated otherwise. Okay? I'm going to do these problems for your video, but you'll probably be fine for them. Okay? Thanks. Wait for the bell. All right, last couple problems. So we have this graph. You should make this, this should be familiar from your quiz. So we have 3 questions. Before we do the questions, let's just figure out the areas here. So the trapezoid, width of, or height of 2, so it's 1/2 times 2, that's just 1. So you just have to add up your heights of 1 and 2, so this is 3. This is a rectangle 2 by 2, that's 4. Triangle, a 1 by 2 triangle, so area is 1. This is a 2 by 2, so the area would be 2. Since it's underneath the x-axis, this would be -2. So first one, the integral from 7 to 5 of f of x plus 3. So 7 to 5 is right to left, so it's going to be the opposite of whatever it is from 5 to 7. So let's think about 5 to 7 plus 3. Well, we have the area from here. If I move everything up 3, well, then we're going to be adding in that rectangle of area. So it's going to be f of x plus the rectangle. That would be, so it would be this -2 from 7 to 5, or from 5 to 7, plus a 3 by 2 rectangle of area, which is 6. So that would end up being -4. But of course, that would be from, +4. But of course, that would be from 5 to 7. If it was from 7 to 5, it would be the opposite and be -4. Okay, that looks like 21. All right, and if you wanted to see that as well, what we could have done is added 3 to each of these. So, you know, -2 would move up to 1. This would move up to 2, and then we'd have this up to 3. So let's see if this is correct. This area should be 4. Well, it's a width of 2, so this is a trapezoid, so the width of 2, 1/2 times 2, that's just 1. Then we add up our sides. I have 1 and 3, so this is 4, so that's correct. And then, of course, the other way around would be -4. I'm just talking about from 2 to 2, the area, of course, is 0. There's just no kind of, there's no area to calculate. Finally, from 5 to 0 of -3 f of x dx. So it would just be -3 times whatever the area is from 5 to 0. So from 0 to 5 is 4, 5, 6, 7, 8. So it would be the opposite of the area from 0 to 5, which would be -3 times 8. That would be -24. But of course, since it's from 5 to 0, this becomes positive 24. So those are those 3 answers, and those are the last 3 questions. All right. Thanks.